What exactly is the difference between gradient descent and stochastic gradient descent? Let's try to understand. So the normal gradient descent, which also called as vanilla gradient descent, it updates a neural network parameters as following. So the new values of your model parameters equal to your previous value minus learning rate multiplied by the gradient of the loss function. So here for the loss function, I have as an example picked the mean squared error, which is the square of error due to individual points. So yi cap is the predicted value of the output, yi is the actual value, and the difference between them is the error. Then you square them, then you sum them and divide by n to get the mean. So this is called as mean squared error, MSE. So here you note that the gradient descent uses every single data points to make the parameter update. In stochastic gradient descent, however, you don't pick all the points. Instead, you pick one random point. So here also gradient is calculated with respect to some loss, but here it's not the mean squared error. It is the loss with respect to this one random data point j. So yj cap is the prediction and yj is the actual value of y that you are supposed to predict. So the advantage of this is that you are calculating the model parameter update with just one data point instead of, let's say, 1 million data points. So the parameter updates can happen faster. And more importantly, let's say you have a loss function like this with x-axis as the model parameter theta. And if you have a plot like this, where this is where you want to reach the minima. But if you encounter during the normal vanilla gradient descent process, if you encounter a region of, let's say, zero gradient or small gradient, the process is too slow. Even if you encounter one point with zero slope, the gradient descent stops. But in stochastic gradient descent, the advantage is that the loss is not calculated with respect to all the points. It is calculated with respect to one random point at a time. So maybe if you plot the loss function with respect to theta for that one random data point, it may not look like this. It may look like this. And because of that, you are not necessarily at a minima or at a low slope region. You may be at a high slope region. And because of this, the parameter will definitely keep updating, but it will be a little bit rough. So you can expect the loss to increase sometimes it will decrease the overall loss. And finally, if you look at the plot of how the loss changes with respect to epochs, in a vanilla gradient descent, it will look very smooth. It will gradually decrease, but in stochastic gradient descent, it can sometimes increase and it will be very rough, but it will not, it is very unlikely that it will get stuck in the local minima.